Hello, everyone. Thanks, Yuri, for introduction. Today, we are going to talk about event-driven architecture, the modern way of developing software. Event-driven architectures become more and more popular in the recent few years. It gets more and more adoption across enterprise companies. And today, I want to talk about some advantages of event-driven architecture over more classical microservices approach based on request-response model. A few words about myself. My name is Grigory Morozov. I'm a senior software engineer at Diligent. I have over 15 years of experience in software development, mostly focused on the backend and infrastructure. My experience lay in areas of analytics and news analysis. Outside of the work, I'm a father of 7-month-old little princess. I also FIDE master in chess, and when I have free time, I enjoy outdoor activities such as hiking, snowboarding, and climbing. Let's start. So let's take a look at this classic example of microservice architectures. I believe many of you saw it more than once. So what we have here, we have a client that sends a request to order service. The order service in turn requests a few other backend services. So scenario might be like that. Order service requests billing service to process the payment. Then it requests inventory service to check if all items are available. And if it gets successful response from both of those services, it requests shipping service to send the order to the customer. For further discussion, let's assume that each service here has a dedicated team that works on this service. So what are some disadvantages, actually, of this approach? First disadvantage that I want to mention is API call. We use HTTP protocol. It could be gRPC, some others. By the way, as Yuri mentioned, and if you want to learn more about different protocols, Mike will be presenting in October about protocols, so please come and join us. So why API call is a disadvantage here? Because of the waiting. Service needs to wait for the response from other services, and during the waiting, it uses resources, so it's not very efficient. We'll talk a bit more about this a bit later. Another disadvantage is dependencies between services. So order service needs to know the location and API details of all the services that it invokes. Also, there is dependency during deployment. Let's say we need to update API of the billing service. And of course, we need to make changes in order service to invoke this new API. Let's say two teams work on those changes in parallel, one on order service, another one on billing service. If the team that works on orders service finishes the work faster, they still cannot deploy those changes to production until billing service is released. And this introduces inefficiency in the process. So this is not good. And the last disadvantage of this approach I want to mention is low fault tolerance. If any of the backend services return an error, the whole client request is failed. We cannot retry it on the service that where the error occurred. So if we need to retry, we probably can do it from the client side. But in this case, the retry request will hit all the backend services again. Even so, we may need to retry only on one service that actually had an error. So those are some disadvantages of this architecture. To do it better, we need another approach. And here I want to introduce you to event-driven architecture. So when I say event-driven architecture, what do I mean? Usually we have services that send events to some intermediary service, event bus. And then we have other services that can subscribe to one or more different types of those events and receive them when they occur. The core difference of this approach comparing with classic one, each service is completely independent. It doesn't need to know anything about other services in the system. And this gives us a few advantages that we will talk about. When we talk about event-driven architectures, first thing we need to define is what is event. And surprisingly, there is no industry standard for definition for the event. Different companies actually have different definitions. And I looked through them and tried to find some common things that we can use. Most of the definitions agree that the event is some change in the state of the system. Also important that it's something that already happened, not the request to do something. Then event must be immutable. So it should never change. If another change in the state of the system occurs, another event may be sent, but original one should not be modified. And also it's highly recommended to keep event schema backward compatible, or at least have a version of the schema. So in case we need to introduce some changes, we don't break our system. When we move towards event-driven architecture, we need to understand some new challenges that may occur. In event-driven architecture, we usually have such things as eventual consistency, asynchronous processing. Also, we may not always have exactly one's delivery of the event, which means that a service may receive the same event more than once. And also the order of events are not always guaranteed as well. So the consumer of the event may receive events in a different order than they were sent. To help mitigate those new challenges, it's recommended to include a few properties to the event metadata. First of all, it's a unique identifier for the event. So in case a service receives the same event twice, it can check that an event with this identifier was already processed and do not process it again. Another must-have property is event type. We obviously need to distinguish between different events, for example, order created and order canceled. Then we have time, another very important attribute. When event occurred, for example, when order was created. And this can help us resolve situations when we receive events in a wrong order. Using the time, we can reconstruct the correct order of the events. The last property I mentioned here is more optional, but still recommended to have. It's a correlation ID, and this allows us to preserve information if two events relate to each other. So we can save first event ID as correlation ID to the second event. Now let's talk about event structure. Here I use a JSON format. It's not mandatory. Some people prefer to use binary formats. In my opinion, if you don't need to process millions of events per second, JSON is better. With JSON is a readable format, so if you need to debug your system, you can always open and look at your event and see all the details without using any serialization tools. Also, there are two main approaches to the event structure. One of them is to put all the details inside the event. Like in this example, we have ordered items, shipping details, billing details, all in the same event. This might be handy for consumers of this event because they do not need to look up for these details in other places. However, it also has some disadvantages. One of them is that it increases coupling between services. So the service that sends this event would need to get all this information. Also, it needs to know that some other services down the line need this information. Another potential disadvantage here is, for example, shipping details and billing details may contain some sensitive information about user. And passing all this information around the system is not very secure. We do not always know from the beginning what services would subscribe to this event. So this is potential concern. The opposite approach is to put minimum information inside the event. Like in this example, we have only order ID. And usually with this approach, we try to put maximum only identifiers in the event. In this case, consumers of the event would need to find other information about this order somewhere else. But it doesn't have disadvantages of the previous approach. And later we will see example where both structures might be used. Okay, now let's return to our original example of microservice architecture. As we mentioned, there are a few disadvantages: API calls, dependencies between services, dependencies during deployment, and low fault tolerance. Now let's see if we can solve these issues using event-driven approach. So the simplest way to introduce event-driven architecture here would be to replace all our HTTP calls with communication through event bus. Let's see if we solved all the issues that we mentioned. There is no HTTP calls. So we use push model instead of pull model here. So, and there is no waiting. The first issue is solved. Then order service doesn't need to know anything about other services in the system and vice versa. So there's no dependency between services. In terms of deployment, we can now deploy services in any order and any time without breaking the whole system. And in terms of fault tolerance, this design is much better in terms of fault tolerance, because now we can retry errors on particular service, not on the whole system. Also, if one service is temporarily down, it doesn't mean that we lose client request. We still can preserve event somewhere in the queue and process it later when service is up again. So seems we solved all the issues that we mentioned. However, I put the word naive in the title of the slide, and there is a purpose for that. It's because we have this hidden dependency. So let's say we need to add some new details in the event that billing service should use. What would we expect when we introduce this feature? Well, we need to update our client application to send this new information, and we need to update our billing service to use this information, right? But with this approach, it turns out that we also need to update order service that needs to put this information inside the event. And yes, here we use the full event structure with all the details. So this is obviously not ideal. We don't want to update order service when we need to change only for billing service, right? So can we do better than that? Yes, we can. And I will show you 3 different possible solutions for this system. First solution, we can make our client to send event directly to event bus. Problem solved, right? We don't have dependent orders service in this in the line of this event processing. Every service now is completely independent. If we need to add new details to the event for billing service, we need to update only client and the billing service. Problem solved. However, this approach has one potential disadvantage. Here, because client needs to talk to event bus, we need to expose our event bus to the public internet. And depends on the solution that you use for event bus, it may be acceptable or not acceptable. Some of the solutions that you may use are not secure enough to be open to the internet. In some cases, some solutions you may want to use only inside your private network. If this is a big concern for us, I will suggest you another solution. In this case, we split our create order request in several steps. First, client will send create order request to order service, but this will not trigger the order processing. It will only create record about the order in the system, and client will get an order ID. Then using this order ID, client can save information in different services related to this order. And after that, client would send place order request to the order service. And this will actually trigger the order processing. Now each service already has information it needs to process the order. The benefits of this approach, we can use slim version of event. So order placed event, in this case, contain only order ID. Our event bus can be placed in our private network. And also each of the services gets only information it needs to have, not all the information about the order. So our security posture here is much better. Then I'll show you one more potential solution to this. And this solution is using orchestration pattern. With this solution, we again use the full model, the full event structure with all the details. And here we use additional service that manages the processing of the event. So this service will send event and to each service involved in the processing of the order. If you're using AWS platform, you can use AWS step function service to configure this process very easily. If you're on some other platform, they may have similar solutions, or in some cases, you may need to build it yourself. But this is also a possible solution to this system. We keep that keeps all the advantages that we mentioned. Okay, that was our example. Now let's talk about some benefits and advantages that event-driven architecture gives companies and people in different roles who are using it. Can we deliver this new feature in 2 weeks? Or actually, we promised our customers to deliver it in 3 weeks, but can we do it faster? How often do you hear such questions about estimations? Me personally, I hear them almost every day. They can be addressed to me or to one of my colleagues, but it's a very common situation in software development. With event-driven architectures, we can give much more precise estimations because when we use this approach, each service is small and independent. So the scope of the changes when we need to implement new features usually also very small and under control. And this is what allows us to give more precise estimations. Also, because again, services small and independent, teams can work on services in parallel, and they can deploy them in parallel in any order without any dependencies. And this allows us to deliver features faster. At the same time, this approach has all the advantages of classic microservices architecture. We still can choose what the language and what framework we use for every service. But also we have such things that teams do not depend on each other, because services do not depend on each other. Therefore, teams are also do not depend on each other. And all this together gives teams much more autonomy. If we need to add more people to the project, it's also easier to do with event-driven architecture. When services are independent, the new person who joins the project doesn't need to learn about all the system to start contributing. It's enough to learn about the project that he is working on. So this is another advantage. Cost efficiency. This might be a little bit controversial topic. You may say, well, we need to have at least one additional service for event bus, and if we use event-driven architecture, and we need to install this service somewhere, or we need to use some managed solution in the cloud. Also, we need to learn about this service, how to use it. And of course, there are some additional costs associated with that. However, there are actually more advantages in the event-driven architecture that allows to reduce costs. One of them we already mentioned, we can deliver features faster. If we can deliver features faster, well, we can sell them to the customers faster. Teams are more efficient. But another aspect of the cost efficiency is more efficient usage of compute resources. Let's take AWS Lambda as an example, but this actually applies to any microservice that you would use. If you use AWS Lambda, you pay for the time it's running. And then if in classic microservice architecture, if we make HTTP call from the Lambda, while it's waiting for the response from other service, it's still running and we're still paying for that, while Lambda doesn't do any efficient work. On the other hand, if we use event-driven approach, there's no those HTTP calls and waiting. Lambda is invoked when some event occurred. And at this point, Lambda can do some efficient work without waiting. Let's go further. So when people talk about microservices architecture, it's often mentioned as a big advantage of microservice architecture that services can be scaled independently. And that's true in many cases. However, let's take a look at this example. Let's say we have a client that sends HTTP request to service 1, and then service 1 sends another request to service 2. Let's say at some point we have increased load on our system. We have more requests. Service 1 cannot handle the load, and we need to scale it up. Good. What happens next? Most likely we will start getting errors from service 2, because after we scaled up service 1, the load on service 2 increased. And most likely we will end up scaling up service 2 as well to handle the load. So not really independent scaling here. If we try to solve the same issue using event-driven approach, one of the solutions could be to put a queue in front of service 2. In this case, when we scale up service 1, it starts sending more events to the queue, but it doesn't result in errors on service 2. Service 2 pulls messages from the queue and processes them on the pace it can. So we don't lose client requests because of errors. And then we have a choice. We can scale up maybe service 2 to process queue faster, or maybe it was a temporal spike in the load, and service 2 will eventually process all events in the queue. Okay, simplicity and decoupling. Those are some advantages that we would expect from classic microservice architecture as well. Each service, and because we split system into small services, each service can be simple enough. And also decoupling is also one of the attributes of microservice architecture that is often mentioned. However, as we saw in previous example, with event-driven architecture, sometimes we can achieve much better decoupling than with classic microservice approach. With event-driven architecture, error handling is also much easier. We can retry errors on particular service where the error occurred. Also, if one service is temporarily down, it doesn't mean that we lose client request. We can save events in the queue and process it when service is up again. So overall, fault tolerance is much better with event-driven approach. Another important component of any complex system is observability. And with event-driven architecture, we get significant part of it for free. This is because when we build the event-driven solution, we use some service as solution for event bus. And all of those services, they come with built-in metrics. So you don't need to write any code for that. You just get all those metrics for free, and you can answer questions such as how many messages they have in particular queue, or what is the throughput of my system, and many others. As an example, I want to show you this dashboard from RabbitMQ. RabbitMQ is one of the solutions that you can use as event bus. And here you can see that we have a lot of different metrics, and even the whole dashboard is all built in. You don't need to write any code for that. And then if you prefer other tools for monitoring and observability, you can easily export all those metrics into Grafana or Datadog, or whatever tool you prefer. And what's important here, this is true not only for RabbitMQ, this is true for any solution that you would use for event bus. When we talk about testing and debugging, there are different aspects to it as well. Let's start with testing. If we talk about low-level tests, like unit, component, service level tests, because in event-driven architecture, services are independent, the testing becomes easier. If, let's say, you don't need to mock that much dependencies because there are almost no dependencies. If we go higher on the testing pyramid and talk about system level tests, when we think about system level tests for in event-driven architecture, we may need to take a little bit different approach, use a little bit different techniques for them. And this is because in event-driven architecture, we have such things as eventual consistency and asynchronous processing. But it doesn't make system tests harder, just need to use a little bit different techniques for that. When we talk about debugging, when you have independent service without dependency on other services in the system, the debugging becomes much easier because you can debug the service in isolation. And you can use event-driven architecture anywhere, on-premise, on any cloud platform. Everywhere you can find some services that you can use as solutions for event bus, for example. Those services might have a little bit different attributes, properties in terms of delivery guarantees or order guarantees. So, of course, before using it, you would need to learn more about those services. However, no matter on which platform you are, you can build event-driven architectures. And here I want to elaborate a little bit more on the subtitle of the presentation, the modern way of developing software. According to the recent surveys, over 85% of enterprise companies acknowledge the importance of event-driven architectures, including 13% that fully adopted it and others on different stages of adoption. And some fun facts at the end, we say that event-driven architecture becomes popular in the recent years, but apparently it is known for about 20 years, since early 2000s. There were a few articles from Martin Fowler in his famous blog in mid-2000s. So everything new is well forgotten old. And that concludes my presentation. You can find me on LinkedIn by my name, Grigory Morozov, and I'm happy to answer your questions. We have more questions in the chat. What if your event bus goes down? Well, usually event bus solutions, at least all that I know, they are built as a cluster, so it's hard to put them down. So if you use RabbitMQ, you build a cluster of a few nodes. If you use Kafka, I think you also build a cluster. If you use cloud solutions, it's a managed service, and usually the cloud provider guarantees that it won't go down. At least the probability of event bus, that event bus, especially in the cloud, will go down is much less than your application, one of your application services will go down. Is there redundancy for event bus? Depends depends which solution for event bus you use. For example, if you're on AWS platform, you can use SQS as part of your event bus solution. It doesn't have to be only SQS, it can be combination SNS plus SQS. See a few more questions. So does IDA increases complexity in terms of authorization? It depends, because as I showed you at least three possible solutions for the same system, and in two of them we keep using APIs. If you use APIs from the client side, so let's, in this solution we use API, and we can do authorization on the API side. And in this solution, we also use APIs of different services, and we can use authorization on the API. Usually, there is no additional authorization on the backend. And if we make our clients talk directly to event bus, as I mentioned, this might be a concern because not all event bus solutions would provide the same level of security in terms of authorization. Hopefully I answered this. Can you think about a scenario when event-driven architecture would not be practical or a good solution? Yes, if you have a very small team if you have one small team that works on startup project, or if you work on your personal project, event-driven architecture probably would be overkill, and you may prefer to use not even microservices, but maybe even monolithic architecture in this case, because overhead, of course, when we use microservices and event-driven architecture, there is some overhead on that. Also, it might be not a good solution if you really need strong consistency, if eventual consistency doesn't work for you. But in my practice, it's a very rare case when you really need it. How far can we go with EDA? I mean, is it always good to send receive events for all services? Maybe there are some cases when making direct API calls is better. Yes, there might be such cases. For example, from the client, side, you usually make API call, not request to event bus. So even so, I showed this as an example. And if you need to show some response to the client right away, or return some result of operation right away, you may not want to use event-driven approach. However, even in this case, I would try to think how you can redesign your project that it may not be required. Sometimes we build system in this way because it's we get such requirements, but I would always question if this is a real requirement, if this is really what customer need, or if we can do it in a different way. Is there a situation when you may need to cancel many events from a queue as they are not relevant anymore? Examples. So yes, one of the properties of the event, well, not properties, but yeah, let's say property, that events value decreases over time. So sometimes events that is from yesterday or even from a few minutes ago may be not relevant anymore. And yes, in case if services was down for some time, we may have a queue of the events and we may not need some old events. There might be different solutions to that. Also depends on what event bus solution you use. Some system allows you to have additional attributes that, for example, time to leave to the event, and if event is not consumed during until it expires, it will be automatically deleted. So again, there might be different solution. Usually depends on what event bus solution you use. Also, if you're already working with a monolithic application, the shift to EDA might be not worth it. Again, it depends. If you have a small team that and you don't plan to expand anytime soon, yeah, you can keep working on monolithic application. Also, if you don't feel that you have any problems with your application, probably you don't want to change anything. However, usually a company tends to grow, and you have, if you want to add more teams to work on the same project, you will want to change your architecture from monolithic. How to ensure event delivered to destination, at least one. It also depends on the solution that you use for event bus. Most of the solutions have some guarantees. I think almost, not all, but most of them guarantee at least one delivery. Very few guarantee exactly one delivery.
But the most important is that some infrastructure pieces might be missing during configuration, and in this case, like issue might occur. For example, if you have, for example, like you're using RabbitMQ, you have Exchange and you don't have queues. I mean, you have queues, but you don't have binding between them. It might be an issue. The same as SNS, SQS binding for AWS and so on. This stuff might happen. If you didn't configure, it might happen. But if you configure, there is guarantee at least once.
Yes, and this is a good point that Yuri mentioned, that it's configured on infrastructure level. So by update, you configure it once and it works. If no matter what you change in your application code. So this is also important in that you can move it to infrastructure level, the mapping of the events to the services. Similar to Joe's question above, I have heard anecdotes about developers struggling with dropped events in event-driven architecture system. Have you or anyone else have encountered any challenges around this? Dropped events. Well, as Yuri mentioned, if there is a misconfiguration and we don't have proper configuration for the rule of event to the service, or we don't have properly configured binding between Exchange and the queue, yes, we may lose some events, but as we mentioned, it should be configured once, and then normally it doesn't break because you normally don't touch it anymore. For AWS, they guarantee at least once delivery. DLQ is another topic. Yes, this is another pattern, I would say. The letter Q, you can, in many solutions, on AWS, in Rabbit, probably in others as well, you can attach the letter Q to your main queue, and if after some retries event is not processed, it can go to that letter queue, so you don't lose event, but it doesn't block other events in the queue. Well, yes, all event buses support at least once delivery. However, you may configure some event buses that they would not guarantee it. For example, I know in RabbitMQ you can not enable persistency for the events, and in this case, your throughput may increase, but you may lose some events. So it's you always can configure it as persistent and not lose events. So and you will have at least once delivery guarantee. I think we covered all the questions in the chat. If I didn't miss anything.
But we still have time. I'm going to stop recording, and right now our official part is done. I want to thank you everyone for joining this meeting today. We really appreciate that you invest in your education, and we are ready to support you during this journey. Like, don't hesitate to reach out to us. And of course, Grigory, thanks a lot for this presentation. We know like you are very busy right now. Thanks a lot. It was definitely great. Hopefully, it's not the last one. Yeah, thanks a lot. Let's round of applause for Grigory, if you can, virtual or not virtual. Thanks a lot, man.
Thank you, everyone.
Thank you so much.